On lesson 8.1, this is just one of the ways to get the graph of a quadratic function. In fact, it's the way that we could do for any type of function, but we are specifically in quadratic functions right now. So one way, the first way I'm going to teach you, which you, like I said, have already done, is to pick x values, substitute those in, and what do you get when you substitute those in? What's the result? You get the y value, yeah. You get your y value for that ordered pair. So you substitute an x value in to the function, and your output should be a y. You can pick any value you want for x. Now, what do I mean by that? Well, let's just look at our standard form is y equals ax squared plus bx plus c. Can you think of any number that you could not put in there? In other words, it would become undefined, or, like what's one thing that makes, like as we're trying to operate, it becomes undefined? What's one thing we can't do? You can't divide by 0, right? Can you multiply by 0? Can you divide into 0? Yeah, you can divide into 0. 0 can be upstairs and be a numerator, but you can't divide by 0. Is there anything else that we can't do that becomes undefined that you can think of? You put it into the function, into the equation, and your calculator says, error, can't do this. Anything else? Okay. Well then, can you think of any numbers? It seems like since the only thing we know is undefined, at this point anyway, is that dividing by 0. Would we ever divide by 0 in the quadratic function? What do you think? Would we ever, Jacob says no. Would we ever divide by 0 in the quadratic function? No, here we're going to square our x value. So if we put 0 and we're going to square it, what is 0 squared? 0. And then here we're going to put, if we have to put it in and take it times the b value, well, can we put 0 in and multiply it by something else? Yeah. So in reality, there isn't an x value. There isn't anything on the number line, anything from the real number set that we can't put into a quadratic function. Even numbers like 2/3. We can square 2/3. We can multiply by 2/3. So in reality, we can pick any value we want for x. So in a quadratic function, we say that the domain, remember this? Domain, gotta dig back a little ways, back maybe to chapter 4. What's the domain? What's that? The x values, yeah, it's the set of x values. And so we could say that the domain of a quadratic function, if we can put anything we want in for x, what would we say the domain is? Well, instead of infinite, there's another way we set it before. The whole number line, all real numbers. All the numbers on the number line are considered to be from the real number set, all real numbers. And remember our abbreviation for that was this. Do you remember this now? I wonder whose classroom you're in, because I could have swore I taught this. Okay, so when we have a quadratic function, the domain is all real numbers. Sometimes when we talk about it, we have parts of the all real number set. We have parts of our domain that aren't reasonable, like, can't really, if x is representing time, let's say x is representing time in the quadratic function, would it be reasonable to say that the domain of that particular function was all real numbers? What do you think? What if x in the quadratic function was representing time? Does it seem reasonable that we would say x could be the whole number line, all real numbers? What do you think? Got some head shakers, yes. I got some head shakers, no. Somebody want to justify their position on this? Abby?
You can't have negative time.
Yeah, there's such a thing as negative time. So there would be no reason to put negative x values into a quadratic function where x was representing time. And typically, in quadratic functions, that is what x represents when we know what the quadratic function is representing. Often, it does represent time. So sometimes we have to think about a reasonable domain. But in general, when we have no idea what the quadratic function is representing, the domain is all real numbers, all the time. Okay? Well, the y value, since that's dependent on what we put in for x, does that mean then that the y value can be any real number also? What do you think? What do the y values make up, by the way? What's that called?
Range.
The range. Therefore, the range of a quadratic function, the y value is dependent upon the chosen x value. Therefore, the range, well, so does that mean that if we can put in any value we want for x, then we should be able to say that the range for a quadratic function would be all real numbers also? Think about the graph of a quadratic function. What does it do? It does this U-shaped thing, doesn't it? And it can be opening up or it can be opening down. So when you think of that on a graph, I want you to think about that on a graph. I'm just going to be random and draw one. Oh, let's say it's like that one, okay? Let's say it's that one. Would the range for that one be all real numbers? Because it starts going down, and by the way, it's hard to envision that the domain is all real numbers because it looks like it's really only in this, like this section, kind of like right here. It looks like, it's really only in that. But this keeps going and going and going, and as it's going, it keeps going out and out and out. That's a funny looking U. So the domain is all real numbers, but the range, it was going down. Been coming down out of infinity up there. It's coming down, 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 and then whoops, what happens? It stops and turns and goes back up. So the range doesn't keep going down. It stops and says, oh wait a minute, I'm not going any further than this, and I'm bouncing back up again. Or what if it was like this? What if it was that way? In other words, it's starting down there, and then it's coming up and up and up and up, and then all of a sudden it stops and turns and starts going back down. Does the range just go, does it keep going on forever and up? No, it stopped and it turns. So when we talk about the range, it's either going to begin at the minimum. It's either going to begin at the minimum, the y value of the vertex, or it's going to or begin at the maximum, because here, and what we're going to have to do is we're going to have to state them as inequalities. Okay? We're going to have to say, oh, well, y has to be greater than something or equal to it. Here we would have to say y has to be less than or equal to something because it doesn't go any higher than that. So you have to be more careful with the range. The domain, you get to just almost be brain dead and say it's all real numbers. But the range you can't be brain dead on. Okay, so this is number 4 because we're carrying on from yesterday. Use the given table to graph the function, then state the domain and range. What I typically do right now while we're learning how to graph using tables of quadratic functions, I typically give you the x values. Even though the domain can be anything you want, you can pick whatever you want. Some of you crazy people in here might want to pick some fractions. How many of you is that? None of you. Well then, I pick them so that you'll get a good graph, you'll get a good picture of a graph. Because here's what can very easily happen. You pick some x values and you're just like, I never like working with negative numbers. I hate fractions, but I even just as much almost dislike negative numbers. So you always pick 0, 1, 2, 3, and 4. Because I say you have to have that minimum of 5 points for a quadratic function. So you just say, I'm going with 0, 1, 2, 3, and 4. Every time. But if you do that every time, you may not get a good picture of the graph. You might just get something like this. Or you might get something like this. because of just how the quadratic function operates. So I typically pick x values for you for a while until you're good at this. Okay, and then when there's fractions involved, I also say, you know what, I know that they like integer values, so I'm going to help them out there too. Okay, so we're going to graph y equals 1/2 x squared. What's a equal in this one? 1/2. What does that tell us about how our graph better open when we're done with it? It better open up. This better open up. Let's see if it does. When we're all done, it better open up. So in other words, we don't just graph it, but we also know some things now that we want to use some reasoning powers. Okay, so we're going to substitute in -4 has to go in parentheses because it's negative and being taken to a power. Well, what is -4 squared?
16.
16. What is half of 16? 8. Positive 8. So we now have ordered pair -4, 8. Okay, you go ahead and fill out the rest of that table, because of course I know you know how. I'll do my own. I have my 5 ordered pairs to be compared by 5 before you start graphing. Feel free. If you're going to be confident, go ahead and graph yours. There we go. I'm feeling pretty good about my graph because it's opening up. At least I got that. What's the vertex of this one? 0, 0. Let's just, I know you have to do some identifying of the vertex in the homework, so let's just do that right now. The vertex is 0, 0. So in other words, does this graph have a minimum or a maximum? A what? A minimum. In other words, it comes down and then it's, not going to go anymore, goes back up, it has a minimum. What is the minimum? 0, no, remember it's just the coming down, it's just the y value of the vertex, it's 0. So the minimum, let's write that too. The minimum is 0. The y value of the vertex. Okay, what's the highest or lowest it goes? Minimum says lowest, maximum says highest. Okay, what's the domain of this function, y equals 1/2 x squared? All real numbers. Remember, this is the no-brainer one. All real numbers. Even though right now it's looking like, well, I don't know, she went from -4 to +4. Isn't it just that? No, remember, I just chose some values that were going to give us a good picture of the graph, but we could have used -10 million if we wanted. Of course, it would have been kind of hard to put that one on a coordinate plane in the size we would be involved with. But. Okay, what's the range? Remember, the ranges are the what? Y values. So what's the range of this one?
To 0.
Anything what?
Anything greater than 0.
Anything greater than 0?
Or equal to 0.
Or could be equal to 0 too, couldn't it? And so we would write that as an inequality. We would say, instead of, I'm going to guess you don't want to write that in words, do you? Okay, so y, remember that's our range, y has to be greater than or equal to 0. There we go. Y will not ever be negative in this one. Okay. Anybody have any questions or observations or anything? No? Okay, then let's go on. I think you get one more we're gonna do. Use the given table to graph the function, then state the domain and range. Oh, one more with a negative sign in, yes. Okay. So again, I picked some x values for you. That negative sign that's right there is not part of the x. Negative 3 is going in for x. That has to get squared. And then after we evaluate all of that, we're going to add 1 to it. So what does that negative sign, negative 3 squared, become? 9 or negative 9? Negative 9, because negative 3 squared is positive 9, and then we have to give it that negative sign, or we could say to ourselves the opposite of 9 is negative 9. So we really have here negative 9. I think it might be a good idea to put that in your notes, that we really have a negative 9 there. Because there's lots of people, here's what they do. They say, oh, the opposite of negative 3 is 3, and 3 squared is 9. No, that's not going to work then. That graph's just not going to work. Oh, by the way, what is the a value of this one? Let's do that. What's a? Negative 1. So it should open what way? Opens down, because why? Negative a value. Okay. So we're anticipating that this better be a parabola that's opening down when we're done with it. Okay, go ahead and complete that table also. Okay? Finish this. What is negative 9 plus 1, by the way? Help me. Okay, thanks. And go ahead and graph your points. Notice this time we have 7 of them. Sometimes I like to do more than 5 and get a better graph. So sometimes I might pick more than 5 x values for you to do. And sometimes it's hard to do a full pencil thing. Sometimes it's best to start at the vertex and do one arm of your parabola and then go back to the vertex and do the other arm of your parabola. Drawing them is sometimes rather interesting. Okay, are we happy with our upside down parabola? Why? Because A was negative, so we're feeling pretty good about that. Feeling pretty good about that it has this nice U shape. Okay, what is its vertex? Let's identify it. What's its vertex? 0, 1. Okay. Does this graph have a minimum or a maximum?
Maximum.
A maximum. Okay. When they open upside down, they have a maximum. And what is the maximum of this one? 1, the y value of the vertex. Okay? You go ahead and do the domain of range and then we'll compare answers. The domain of this function, y equals negative x squared plus 1, and what is its range? Compare answers with somebody across the room. You gotta get out of your chair. Get up. Lethargic. Get up. Compare answers with somebody across the room. Find out what somebody else has. Go. Get out of your chair. You cannot talk to a neighbor. It has to be somebody else. A ways away. You gotta walk. And if you didn't have it, you better make sure that they convince you why it is what it is. Okay, Brendan still needs somebody want to have another visitor? Oh, he's going over there, Kyle. Okay. Okay, so you're all feeling really confident now you're going to give me the right answer. Okay, what's the domain? All real numbers. Oh yeah, that's right. That's such a no-brainer. Okay, what's the range? Y is less than or equal to 1. Agree? Or in other words, it never gets any higher than negative 1 on the graph. So y is less than or equal to negative 1 or positive 1? Positive 1, okay. So this is, we have to have an understanding still of domain and range. That is something that's huge when you're working with functions throughout mathematics from here on out. Do you understand what that means? And how do I find it? How do I know what it is? Okay? Anybody have any questions that need to be answered before I send out the graph handout to you and you get to work at home? Okay.